Hey, what's up, you guys? Mr. Deaver here. So let's pick up right where we left off yesterday. Remember that balloon stuff? We had these balloons that would like stick to the ceiling or would make a little piece of plastic like levitate and float. And we're like, what's the deal with that? What could cause that? Well, what causes it is different electric charges. What in the world is that? Well, to understand different electric charges, we have to start out with the real basics, okay? We have to start out with the atom. Yeah, that's right. That mysterious stuff we saw yesterday starts out with understanding the atom. So, let's do a quick review of the atom. All right. What do they call the center of the atom, the middle part? Starts with an N. That's right. It's the nucleus, okay? The nucleus is the little center part of the atom. And in the nucleus, we have two different kinds of particles. We can have, remember them? One starts with a P, protons. Okay, we can have protons, and protons are always positive, so we make a plus sign inside of them. Protons have a positive electric charge. So here you can see I have two protons. And then the other ones start with an N. Remember those? Neutrons. Yeah, neutrons. Okay, so our neutrons, which I'm going to color blue real quick here, our neutrons have no charge. Neutrons are neutral, no charge. Okay, then you probably know, this is going to start looking familiar, there's this kind of like ring that goes around the nucleus. And there's different names for this, energy levels and electron shells and all kinds of things. But basically, what we need to remember is that the electrons can be found out there in this outer level, okay? And let's put a minus sign on them because electrons have a negative charge. So look at that. We got positive protons and we've got negative electrons. Now let's count them up and see if this is a balanced atom. 1, 2 positives, 1, 2 negatives. Guess what, ladies and gentlemen? This atom has a net charge. Okay, there's a word for you. A net charge of neutral, nothing, of 0, because the two positives balance out the two negatives. So, as you can see, this particular atom is neutral. The net charge would be neutral. The whole atom is a neutral atom. But what if it doesn't come out to be a net charge of 0, or a neutral net charge? What happens then? Let's take a look. So take a look at this example. Here we have another atom that has 2 positive protons and 1 negative electron. What's the net charge? Well, the net is going to be plus 1, okay? Plus 1. We have one more positive than we have a negative. And so the overall atom is going to be what we call a positive ion. All right. Well, what about this? What if we had an atom that had one more electron than it had protons? Well, then it's going to be net negative by 1. And we would have what's called a negative ion. And why is that significant? Because this is the base, or the start, of all of these electric charges, these static electric charges that we've been talking about. If you have two different charges, a positive and a negative, these two things will be attracted to each other. Okay? Opposites, this is the way I like to remember it, is that opposites attract. All right? But what if we had the same charges, like let's say we had a positive charge and another positive. So we have a positive atom and another positive atom. Now they're going to repel. Or if we had a negative atom and another negative atom, they too will repel. So opposites attract, similar charges repel. And that, ladies and gentlemen, takes us back to the very basics of why we saw these mysterious things happen yesterday in our lab. You see, the balloon, as you rubbed it against the towel, built up a negative charge. If you were also able to get a negative charge on the little piece of plastic, then the two would repel and you could levitate that piece of plastic. But if somehow you got the opposite charge, a negative charge in your balloon and a positive charge in the plastic, then the two would be attracted to each other and the plastic would stick to the balloon. And the same applies for kind of all of the other little games that we tried, including sticking the balloon to the ceiling or having it deflect a stream of water. Opposites attract, similar charges repel. And it all starts out way back at the level of the atom itself. All right, ladies and gentlemen, that's all for today. Mr. Deaver, out.